G'day E7s and hello, welcome again. And just looking at how many times I can say hello at the moment. I'm going to move on. Next tutorial, we are looking at exercise, I believe, yes, is it up here? 11H, which is looking at volume, and particularly only, really, the volume of rectangular prisms. You can find volume of pyramids and cylinders and all that type of stuff, but we are introducing you to the concept of volume. So we're sticking to rectangular prisms, which are really, really easy. All right, so volume is basically the amount of space inside a three-dimensional object. Okay, so when we're looking at area, that is looking at the amount of space inside a two-dimensional object. Okay, so you're looking at the surface area of a square, or a rectangle, or a triangle, all that type of stuff that we did. But when we're talking volume, we are looking at three-dimensional objects. So picture a carton of milk, picture a prima, picture a box of some sort. Okay, so a three-dimensional shape and how much space is inside that particular three-dimensional object. Okay. Now, volume is measured in cubic units. Okay, so we've looked at things like meters and centimeters and kilometers. Okay, which is looking at a length. We have also looked at meters or centimeters or kilometers squared, which is looking at area. And now we are looking at cubic meters, which is looking at all cubic centimeters or cubic millimeters or cubic kilometers or all those sort of ones, which is looking at volume. Okay, so this is why units are so important, because there's a big difference between just flat out meters, which is length, meters squared, which is talking about area, and cubic meters, which is talking about volume. So again, I'm going over things several times because, again, you need to understand. So you need to take this stuff on board. So expressing it in the correct units is very important during this unit. Okay. Bit of other information here. Volume is measured in cubic units, such as a cubic centimetre, which is 1 centimetre long, 1 centimetre wide, and 1 centimetre high. So think of even a dice. So if I quickly draw a picture here, okay, that needs to come down a bit further. All right, and each of these side lengths are 1 centimetre. All right, that is 1 cubic centimetre. All right, that's what it is. That's what it looks like if that was actually 1 centimetre. All the edges were 1 centimetre long. All right, just like the topics of length and area, different units can be selected depending on the size of the volume being measured. So as I said, millimeters, kilometres, centimetres, all those sorts of things. All right. All right. Some key information. So this is sort of stuff you need to write in your books. And I am noticing in your workbooks that you're obviously not taking them home while you watch these video tutorials, and you're not making many notes, which is then making revision difficult because you don't have notes, making your help sheets a bit more difficult because you don't have notes. So writing this stuff up in your workbooks is actually fairly important. Okay, so key ideas. Volume measured in cubic units. The common metric units for volume include cubic millimeters, this one, cubic centimeters, this one, cubic meters, this one, cubic kilometers. Obviously not drawn to scale, these guys here. So that is what we're talking about. All right. Now the volume of a rectangular prism is given by this formula: length by width by height. All right. Now what do you notice here? Length by width. Where have you seen that before? Yeah. Okay. If you said it. Length by width is how you find area. Okay. Is your length? Oops. That's meant to be an equal sign. By width. So then to find volume is that you are using this formula, length times width. Okay, so you're finding the surface area of a particular two-dimensional object, for example. And if we extended that into a three-dimensional object, then you are just measuring the height of it, or the depth of it. Okay, so you are multiplying that by the height. Okay, so length by width by height, L by W by H. Okay, so that is, and this is again what you need to put into your workbooks, the formula to calculate volume, length by width by height for a rectangular prism, all right, or a cuboid. As it says here, a rectangular prism is also called a cuboid, all right, so if all the lengths are exactly the same, such in all these guys here, 1 millimetre or 1 centimetre or 1 metre or 1 kilometre, all the edges of it, the length by width by height. It is actually a cuboid, so you can actually do L cubed. Okay, but if you stick to this, this will work anyway. All right, so that's my length, that's my width, that's my height. Okay, it always works. So if that is my formula, okay, here is my first problem. So the first thing I do, and which you need to model, write my formula. I'm finding the volume of this particular three-dimensional object. So volume equals length by width by height, if you want to write it. Thank you. Okay, so does it really matter which you include as length by width, your length, your width, and your height? Not really. Okay, so I'm going to just call this 5 centimeters my length, this 4 by my width, and this 10 obviously is the height of my object. Okay, so I'm going to substitute these values in. So instead of my length, I know my length is 5, I know my width is 4, and I know my height is 10. Now I'll calculate it. I'm just going to do it in sections. I'm going to do this bit first. 5 times 4 is 20, multiplied by 10. 20 times 10 is 200. And my units, centimetres and cubic centimetres. That's it. Really, really simple to do. Not hard at all. And that's it. So it's basically just finding surface area, but then adding the height, if it's a three-dimensional object, to find the volume. Really easy. Let's have another example. Now this one's a little bit more tricky because we have a rectangular prism here, okay, but we have a section here that has been cut out of it. So we need to find, so this section here that I'm drawing in, a little bit darker, we need to, that's really poorly drawn, we need to find the volume of this rectangular prism, but this space has been cut out of it. Okay, so we need to find what the volume of the rest of the prism is. So we are finding volume, obviously, length by width by height. Okay, now we've got a bit missing. So we do this like our composite shapes. So we look at what all the measurements we can make, all the calculations we can make, and then we work out whether we need to add or subtract. Obviously, if there's a space being cut out of this rectangular prism, what do you think we need to do? Okay, we're going to make two calculations of the big rectangular prism, and then we're going to make calculations for the smaller one. Do you think we're going to add them together, or do you think we're going to subtract one from the other? Hopefully I said we subtract Mr. because it's a bit of space, it's missing, so we take it away. Alright, so I'm going to calculate the volume of this big prism, the whole thing. So I'm going to pretend this middle bit is still there at this point. Okay, so it's just one big box with my lengths, my widths, and my height all here. So I substitute them in. So my length I'm going to say is 5, my width I'm going to say is 8, and my height I'm going to say is 5 also. So my height over here, the height of my rectangular prism. So 5 times 8 is 40. Multiply that by 5. And 40 times 5 gives us, sorry, I've just got to adjust my pen there for a minute, is 200 cubic centimetres. Okay, so that's for the entire rectangular prism that I have here. Okay, now, alright, we've got another little rectangular prism that's been cut out of it, so I'm going to calculate that volume. So I'm just going to, sorry, if I can, the pen doesn't want to work today. So that's volume 1. This is volume 2. Again, length by width by height, which equals, and this is, what's my length and width and height? So I know my length here is 2 centimeters. What's my width? Well, it's the same entire length of, the width is the same as the entire box, the original box that I just calculated. So that is 8. So that's 8 centimeters along here. So my length is 2. My width is 8, length 2, by width 8, and my height is also 2. Okay, so we work that out. 2 times 8 is 16, multiplied by 2, which equals 32, and my units, centimetres cubed. Okay, so I've got my volume 1 and my volume 2. Now, do I need to find my complete volume of just this box with this section cut out in the middle? So it's been removed, so I've got to subtract. So my total volume, or my final volume, whatever you want to call it, is going to be 200, which is the whole lot, minus the 32 that I have here. So the 32 that's been cut out. So this area that's cut out has a volume of 32 meters, cubic centimeters. So I need to subtract that from my entire big box, and that gives me 168 cubic centimeters. Okay, that easy. Well, that easy? It is fairly easy, really. It's not overly difficult. You've just got to approach it like your composite shapes. What shapes have you got? Calculate the volumes or the areas, whatever one you're doing. Work out, do I add or do I subtract with my final answers that I've got. Okay. Now, if you're happy with that, if you reckon you've got a good handle, you can move away. You can stop this if you like, and so you think you're ready to go with the next exercise for 11H. But I'm going to do this one last example. So if you're looking at it and go, well, how would I do that? Then stay tuned. Okay. So if I'm going to do this again, I'm going to break this shape apart. I'm going to break it up into different shapes. All right. So I'm going to actually break that up. So I've got one box there, and I've got two boxes there. Okay, so that's the way I'm going to do it. So I'm going to do this first box. So if I've got this box, and actually I'll draw that, and sometimes it is better to draw a sketch of what you're looking at. Okay, so I'm just going to draw this guy in, and I'm going to put some measurements on it. Geez, it's a really bad drawing. Okay, so I know this length. Okay, this length here, I'll go with that one, is 8 centimeters. Okay, now what's this side length along here? Okay, from here to here. Well, we know the whole thing from here to there, okay, from there to there is 17. Now, this is also telling us that it's 8 centimeters from here to here. From here to here is 8 centimeters. So from here to here is 8 centimeters. So if that's 8, what must this length be? Okay, so it's 17 minus 8, so that should be 9 centimeters. Okay, so this length along here, which I've drawn up a little bit higher, so I'm just going to draw an arrow, is 9 centimeters. Okay, or this one down here, 9 centimeters. All right, and we need, what else do we need? We need the height, so we need this one here. Okay, and it is a cube, so we can use this measurement here, which is 8 centimeters. So I know the height is 8 centimeters as well. Okay. Now I'm going to actually get rid of this one. Forget this one for the moment. I don't need that. So I've got my length. I've got my width here as well, which is the 8. So I'm going to write the 8 down here, and we'll scrub that one out. Let's transfer it to there. So my length by width and my height. So my volume equals length by width by height, which equals 9 by 8 by, thank you, by 8 again. 9 times 8 is 72 multiplied by 8. And I'm just going to use my trusty calculator for that one, so I'm going to cheat a little bit. 72 multiplied by 8 gives me, what is it, 576. 576 cubic centimeters. Okay, so that's the volume just of this part of my block. Okay, so now I've got to find the volume of my second part. Okay, this one here. So, and these measurements are much clearer. So I know that there is 8 centimeters. I know my width is 16 centimeters. Okay, and I know my height is 8 centimeters there. So again, my volume equals length by width by height. Okay, so my length is 8, my width is 16, and my height is also 8. Okay, so 8 times 16, again I'm going to use my trusty calculator that I have beside me right here, 128, multiplied by 8, again I'm going to use my trusty calculator that I've got right here, and that gives us 1024 cubic centimeters. And if I want to find the total volume of this entire shape, I've got to add this one to this one. There's been nothing taken away. I've got this box, which has been added to this box. Okay, so my volume total is going to equal my 576 plus 1024. Okay, 576 plus the 1024, which gives me conveniently 1600 cubic centimeters. Okay, so that's how you do it. So formula is really easy. Calculating the volume of just simple rectangular prisms is really easy. Once you get to composite type shapes, okay, it's a matter of, again, what shapes have I got, which you're going to be dealing with rectangular prisms. Do I need to add? How many do I need to calculate? Then do I add or subtract at the end to get my final volume total? Okay, and don't forget your units, very important, with the cubed for volume. All right, hopefully that makes sense to everyone. Hope you are enjoying these videos as much as I am making them. And yeah, we'll see you on the next one. See you later.